In this lesson, we will learn about convolutional neural network, in short, ConvNet. It is actually a deep neural network that is specialized for image recognition. ConvNet works in the same way our visual cortex works and recognizes images. It may seem a little complicated at the beginning, but don't worry, I'm here to help. Let's start with the basic architecture of ConvNet. We can divide the entire architecture into two broad sections: feature learning and classification section. The input image enters into the feature extraction network. The extracted feature signals enter the classification neural network. The classification neural network then operates based on the features of the image and generates the output. The feature extraction neural network consists of pile of the convolutional layer and pooling layer pairs. The convolutional layer, as its name implies, converts the image using the convolution operation. It can be thought of as a collection of digital filters. The pooling layer combines the neighboring pixels into a single pixel. Therefore, the pooling layer reduces the dimension of the image. As the primary concern of ConvNet is the image, the operations of the convolution and pooling layers are conceptually in a two-dimensional plane. This is one of the differences between ConvNet and other neural networks. Now we will learn about the convolutional layer. Convolutional layer generates feature maps from images. The working principle of this layer is different from other neural network layers. It does not employ connection weights and weighted sum. Instead, it contains filters that convert images. We call these filters convolutional filters. The number of feature map and the number of convolutional filter is same. That means if there is 4 convolutional layer, then it will generate 4 feature maps. The filters of convolution layer are two-dimensional matrices. To understand how convolution works, let's take a 4x4 pixel image and 2 convolution filters. I'm taking these filters arbitrarily, but in actual ConvNet, these filters are determined through training process. Let's start with the first filter. The convolution operation begins at the upper left corner of the submatrix that is the same size as the convolution filter. Let's apply the convolution. This one will be multiplied with this one. This 0 will be multiplied with this one. This 0 will be multiplied with this 4, and this one will be multiplied with this 6. The result of multiplications will be added together, and the value of that addition will replace this entire block. The result of the convolution will be like this. This 2x2 block will be represented by a single value. In this case, that is 7. The next convolution operation will be performed on these blocks. This 1 will be multiplied with this one. This 0 will be multiplied with this one. This 0 will be multiplied with 6, and 1 will be multiplied with 4. Finally, the results of these multiplications will be added together, which will represent this entire block. In our case, it is 5. Here is the result of this convolution. This 2x2 block has been replaced by 5. Using the same calculation, the next block will be replaced by 9. After that, this block will be replaced by 4. This process will keep going, and the final result will be this one. Here at the final stage, the 4x4 pixel image has been converted into a 3x3 pixel image. The largest value at the final result is 32. and it was generated from this block. Have you noticed the similarity between this block and the convolutional filter? They are similar. Both of them have value at first and fourth position and no value at second and third position. The convolution operation yields large values when the input matches the filter. On the other hand, when we performed convolution operation on this block, it yielded 4. Although it has the same significant number 30, but it doesn't create that large value. It happened because of using mismatching filter. If we use our second convolution filter, then this will be the result. Notice carefully. Here, this block generated 36, that is a large value. It happened because the filter we're using now matches with the input block. This example demonstrates that the feature map will be extracted depends on the convolution filter you are using. Have you noticed there is another layer in between convolution filter and feature map? These are activation functions. Here is nothing special about activation function in ConvNet. They are same as the activation function we used in neural network. Rectified linear unit, in short ReLU, is the most popular activation function. However, we also use sigmoid function and tanh function when we need them. We have covered convolution layer. Let's talk about pooling layer now. The task of the pooling layer is to reduce the size of the image. The operation of the pooling layer is very simple and straightforward. To understand how it works, let's take the same image we have taken earlier to perform convolution operation. There are two types of pooling, max pooling and mean pooling. From a mathematical perspective, calculating the mean pooling and max pooling is convolution operation. The difference between the convolution layer and this convolution operation is stationary convolution filter and the convolution area do not overlap. Therefore, if we take 2 into 2 matrix as the convolution area, there are 4 convolution areas. For the mean pooling, the calculations are done by taking the means of the convolution areas. For example, the mean of the first area is 1 plus 1 plus 4 plus 6 over 4, that yields 3. The mean value of the next convolution area is 1 plus 3 plus 4 plus 8 over 4, which means 4. In the same way, the mean value of next two convolution area are 8 and 3 respectively. This is how the mean pooling values are generated. Calculating the value of max pooling matrix is very easy. Simply take the largest value of each convolution area and form the matrix. The highest value of the first convolution area is 6, second convolution area 8, third convolution area 30, and fourth convolution area 5. The max pooling matrix is generated using these values. These are the theoretical concepts that we need to learn before implementing a convolutional neural network. As we have completed the theoretical part, let's proceed to the practical section. In this section, we will implement a convolutional neural network that can recognize handwritten digits. We will implement the neural network using MNIST database. It contains image of 70,000 handwritten digits, 60,000 for training and 10,000 for validation. Each of these images are 28 into 28 pixel binary image like this picture. However, training a neural network using 60,000 image is time consuming. So I'm showing the process using 10,000 images where 8,000 for training and 2,000 for validation. The digits can be classified into 10 classes, 0 to 9. A 28 into 28 pixel image has 784 pixels. Therefore, there will be 784 input nodes. We are taking a single convolution layer with 20 9 into 9 convolution filters. Output of the convolution filters will be passed through a ReLU function. The pooling layer has 2 into 2 submatrices. Our classification neural network will have a single hidden layer and output layer. It will have 100 nodes and the activation function will be a ReLU function. As we have to identify 10 classes, we will construct the output layer with 10 nodes and we will use softmax function as the activation function of output nodes. This is the architecture of the neural network we are going to implement. There are many layers here, but 3 of these contains weight matrices. So these 3 layers require the training. Here W1 is weight of convolution layers. It is used by convolution filters for image processing. W5 and WO contain the connection weights of classification neural network. There are input nodes between pooling layer and hidden layer. This layer transforms 2D image into a vector. It is not involved in any training operation, so we have represented it using squares. Let's implement the system. Click on the Browse for Folder icon. Specify a location, create a folder there to save your program. Here I'm creating a folder named Implementation. Once you have created the folder, get inside the folder and click on Select Folder button. Our first task is to load the MNIST images. To do that, we are going to implement a function. Let's call it Load MNIST Images. Declare the name of the function, input type, and return type. This function will take MNIST image database as input file and will return image data. We're using fopen function to open the file. The file is a non-text type, so we have to use RV as an argument. This line will show an error message if it cannot open the file. In the next line, we are reading the data from the file we have opened earlier and loading the data into a variable named magic. If there is an error during reading the data, the next line will prompt an error message. The next 3 lines read the number of images, number of rows, and number of columns and store this information into 3 variables named num_images, num_rows, num_columns respectively. In the next 3 lines, we are reading the image, reshaping them using the number of columns, rows, and number of images and ordering them accordingly. At the end, this function returns reshaped 8-bit images. Now let's create a function to load the label. I'm naming it as load MNIST labels. Declare the name of the function. It takes file name as input and returns the label. This line opens the label file, and if there is any error while opening, this line prompts an error message. This line reads the label from the file and stores it in a variable named magic, and if there is any error while reading those labels into the variable, it prompts an error message using this line. This line reads the number of labels and the levels are stored in the variable named levels in unsigned character format using this line. If there is any mismatching while reading the level, this line will prompt an error message. So we have implemented two functions to load images and levels from MNIST database. Let's implement the activation function now. We will use two activation functions, ReLU activation function and softmax activation function. Let's start with creating ReLU activation function. So this is the ReLU activation function. Let's implement the softmax function now. This is the softmax function. So we have implemented the ReLU function and the softmax function. We have to perform convolution operation. So let's implement a convolution function. This function takes two input, x and w, and we're not implementing the convolution function in code. Matlab has already a built-in function to perform convolution called conv2. We are simply calling that function to perform convolution operation. Let's create a function to implement the pooling layer. I'm naming the function as pool. The pool function takes one input and it uses Matlab's built-in conv2 function to perform convolution. Let's implement the function to train our convolutional neural network. The name of the function is mnistconv. It is a pretty lengthy program and beyond the scope of explaining each and every line. If you don't understand a part of this program, please comment below. I will try my best to explain as elaborately as I can. To test our ConvNet, we need to implement a random function that can generate random array and random number. This function will serve the purpose. To train the network, we need to download MNIST dataset. We will train the network using 10,000 images, so download this dataset. You have to download the levels as well. Then create a folder in the directory you are working. I'm naming it MNIST and extract the dataset in this folder. You can remove the zipped version after extracting them. Now you will see the dataset in your current directory. And now we are ready to test our program. To test our program, I've created a function named testMNISTconv. This function calls the mnistconv function and train the convolutional neural network and also show the accuracy of our trained network. This is the first epoch. And this is the second epoch. and the final one. And the accuracy of our ConvNet is 94%. Let's implement a function to visualize the performance of our convolutional neural network. Now we will create a script named plot features. This script will use display network function and will plot the features extracted by our ConvNet. Let's run the program. This is the result of our program. Let me organize it a bit so that you can understand it properly. This is our input image. These are the convolution filters. This is the result of the convolution, And when the result of the convolution was passed through ReLU function, that is our activation function, this result was generated. Finally, when these features were processed through meme pool, we found this final result. This is the end of this lesson. I hope this lecture helped you to understand the concept of convolutional neural network and you were able to implement the code in Matlab. If you have any question regarding to this lecture, write down your question in the comment section. I will try my best to answer it.